Why does insulation lose thermal conductivity over time? Imagine your home wrapped in a cozy blanket that slowly becomes less effective. That's similar to what happens with insulation as it ages. Over time, insulation can become less efficient at stopping heat from passing through. But why does this happen? Let's explore the facts behind this process. Most insulation materials relying on tiny pockets of trapped gases or air to slow down heat transfer. These pockets act like barriers, making it harder for heat to move through by conduction. When the insulation is new, these gases are sealed inside, providing excellent insulation. But as years go by, these gases can slowly escape through tiny cracks or pores in the material. Once the gases leak out and are replaced by regular air, the insulation's ability to resist heat transfer drops. For example, foam boards contain special blowing gases that give them their insulating power. When these gases leak out over about 5 years, the thermal conductivity can increase by 20% or more, meaning heat can pass through more easily. Moisture is another big factor. If insulation absorbs water from humidity, leaks, or condensation, its thermal conductivity jumps. Water conducts heat much better than air, so wet insulation can conduct heat up to 15 times more than dry insulation. Plus, water can chemically weaken the insulation, making it break down faster. This damage can lead to gaps or cracks, which allow more heat to pass through. Chemical exposure also plays a role. Some insulation materials, especially foamed plastics and fibrous types like glass wool, can absorb chemicals from the environment. These chemicals can degrade the material's structure and increase its thermal conductivity. When the binder or waterproofing agents break down, the insulation becomes less effective at blocking heat. Physical changes happen too. Over time, insulation can settle, compress, or age, which reduces the amount of trapped air inside. When the air pockets shrink or disappear, heat can transfer more easily through the material. This process can cause the insulation's thermal conductivity to increase by up to 40% over many years. In short, insulation loses its ability to resist heat transfer over time mainly because gases inside escape, moisture gets in, chemicals damage the material, and physical settling occurs. To keep insulation working well longer, it's smart to choose materials with strong moisture barriers, chemical resistance, and stable structures. Regularly inspecting and maintaining insulation to prevent water leaks also helps preserve its insulating power. This all ties back to how heat moves through materials, by conduction and convection, showing how changes in the material's structure make it easier for heat to pass through as years go by.